Hi, and welcome to episode number 88 of the weekly Google Cloud Platform podcast. I am Francesc and Mark, and I'm here with my colleague Mark Mandel. Hey Mark, how are you doing?
I'm good. I had a nice, relaxing weekend, so it's super good to be back. How are you doing?
Doing great. Also, great weekend of machine learning and sun. So, yeah.
Nice. I did nothing technical. I was at the beach. It was fantastic.
I studied a little bit, but it was fun. I loved it. And today we're going to have a really cool conversation about a topic that we all love, Kubernetes.
Yep.
And specifically about Kubernetes 1.7 with someone that we had been wanting to have in the podcast for quite a while, Tim Hockin, and he's
you want to say his title?
He's a principal software engineer.
I think so. Yes.
Principal software engineer in Google, and he's one of the people that really started the Kubernetes project. So he knows a lot about it, of course.
Super happy to have him on the podcast. Then we're going to have a related question of the week at the end of the episode, talking about what are best practices for how I should use pods, containers, like how should I structure these things?
Yeah, you can put all of your things in a container. Does that mean you should?
Should I?
So, we'll talk about that at the end. But before that, we have our cool things of the week, as usual. And the first one is something that I have used before, especially for demos. And it is super cool. I'm pretty sure most of you know about Cloud Shell, which is that little shell that you can get directly from the Google Cloud Console, for which you don't even need to pay. It's like that little shell that is part of your project. So you have all the authentication and all the tooling. You have like gcloud and kubectl or kubectl, and all of those tools already installed by default, which is really cool. Now it also comes with an editor. So if you don't want to edit your files with Vim, I don't know what you're doing in your life, but
or Emacs,
but you rather edit them like a normal person, like with a mouse and moving around.
Yep.
You can now, which is really cool. It's a very simple thing. You just need to go and click on Edit Files on the left side of the Cloud Shell. There's a place that will show you all of the files that you have. You can edit them there, and then you can access those files directly from Cloud Shell. So, for instance, if let's say you're using kubectl. You can edit your .yaml file directly on that editor and then go like kubectl create -f, whatever, which is very nice.
Kube control.
Whatever.
That's fine. But no, it is actually a super cool project. It's based on the open source Eclipse Orion project. It comes with keyboard shortcuts, syntax highlighting, code completion, find and replace for basically a lot of supported languages and configuration files. And
I guess that the new thing is that this is actually now GA. It used to be beta for quite a while, and now is GA, which is really cool. I have been using it, and I definitely recommend trying it if you've never used it before. The second one is about App Engine and video games. Yes, it is about how App Engine helped power Super Mario Run. Super Mario Run is a really cool video game that is available on both iOS and Android. And it was kind of a big deal. And it had like huge scaling challenges because, it's like Nintendo or
Mario,
like Pokemon Go, whatever. Like whenever you make a really big game like this, it's going to go really, really viral. So they explain how they did it to have 0 prompts during the launch, which is pretty amazing. They explain all the architecture and how basically everything is App Engine. But they explain also how they did the push notifications for all the phones, how they make it so it runs faster. So there's a lot of Memcache stuff. And then all the analytics part of the things. So it's like you'll see Cloud PubSub and Dataflow and BigQuery. And then Firebase a little bit sprinkled on top, of course.
Yeah, it's super cool. They simultaneously launched in 150 countries at the same time.
As you do.
They didn't even do so it's quite regular for game companies to do a staggered rollout across nations. Pretty crazy how they did that. The one of the companies behind it, DNA, was able to complete a test with 3 million accesses per second when looking at using Cloud Data Store for their persistence layer. It's pretty awesome seeing the amount of scale they were able to achieve. I would say a pretty successful launch. I was pretty impressed with how seamless it all seemed to go.
Yeah, and the cool thing is that I think it was like last week or 2 weeks ago that we used as one of the cool things of the week, that little video that explains a little bit how Mario Run was done. Well, that video is part of the blog post, but that doesn't give any detail compared to how detailed the rest of the blog post is. So definitely go read it, even if it's just to see Super Mario running and jumping around.
Cool. And so finally, last cool thing of the week is a series of 7 hands-on labs for scientific data processing on Google Cloud Platform, through going through plotting recent earthquake activity to building image processing with Apache Spark, to machine learning and a variety of other ones as well. There's a variety of technologies too. So it's not just TensorFlow, it's a bunch of stuff. And the nice thing is you can either do this as just like a step-by-step. So if you have your own GCP project, you want to do it that way. So it's available basically with the static documentation. But you can also do it through Quick Labs as well, which means if you just want to have Quick Labs fire up a quick GCP project for you temporarily without you having to do a lot of the work, it's able to do that as well, which is super nice. There's a whole bunch of really interesting stuff, from TensorFlow to just using BigQuery.
This is really cool. I feel like after spending the weekend doing machine learning, this may be a good continuation. I really like that one of the projects is to predict the correlation, not causation, even though in this case, I'd say that it's highly correlated, of the mean daily temperature versus how many people call 311 complaining about their hot water not working. Surprisingly, people complain more about the hot water not working when it's really cold.
Funny that.
Yeah, shocking. Definitely check it out. There's a lot of really cool projects. There's actually a bunch of them.
Yeah, there's 7. It's pretty cool. Yeah. So why don't we go have a chat with our new friend Tim and talk all about Kubernetes 1.7?
Sounds good. Let's do that. So it is a huge honor today to be joined by Tim Hockin. Tim Hockin is a principal software engineer here at Google, and also one of the first engineers working in the Kubernetes project, which is pretty awesome. So, Tim, welcome to the podcast. How are you doing?
I'm well, thank you. I'm glad to be here today.
Thank you for joining us. We're going to be talking today mostly about Kubernetes and the latest version, 1.7. But before we get started into all the details and new features and stuff, why don't you tell us a little bit about yourself and what you do here at Google?
Sure. Well, I've been at Google a very long time, but most recently I've been working on the Kubernetes and Google Container Engine projects. I was one of the first engineers on the project, one of the original 4, I like to say. I work on things like networking, storage, API, Node, federation, plugins, cloud provider, those sorts of things, mostly the lower level parts of the system, the infrastructure for the infrastructure, if you will. I'm also working on things like governance and steering committee, setting overall direction for the project, both inside Google with Container Engine and with Kubernetes proper. Though I reserve the right to hold opinions on things that I don't necessarily work on, which I think every contributor to the project has probably run into. I also do a lot of outreach and evangelism. I go and talk to a lot of customers and users and would-be users and conferences and those sorts of things.
Yeah, I've seen you on stage a couple of times. I gotta say, those talks are really, really good. So
thank you.
You mentioned that you've been at Google for a very long time, and now I'm curious, for how long?
I joined in 2004, so that puts me at 13 years.
Wow. Okay, that's very a long time. Yeah,
Nice. Oh, that's super cool. All right, so we've had several episodes on Kubernetes, but I always love asking this question because we get different perspectives on the project, which I think are really interesting. So if you had to give sort of like a 2 or 3 minute description of what Kubernetes is, if people haven't come to it before, how would you describe Kubernetes?
Kubernetes is, in a sentence, it's a container management system. I think the important part here is that it's a cluster management, and it brings these new idea, or not new, but a different idea of how people should manage their workloads. It takes the lessons that we've learned by doing this for a long time at Google and brings it out and shows people sort of how we work, why we think it's a successful way to work, and brings forward these primitives. So it's somewhat opinionated in that it's got some basic ideas of how we think you should do things, but it's not very opinionated in that there's a lot of flexibility and you can do things in many, many ways within the bounds of Kubernetes, and you can evolve your operations over time. We bring this idea that you should manage your workloads in aggregate instead of in singletons. You should not be thinking about, which particular instance of your application is doing what. You should be thinking about the number of replicas you need and the scale out, and the resources should be allocated and managed by the system automatically. These are not problems that humans are good at thinking about. We should let the machines deal with those problems.
Awesome. You mentioned previously as well that you do some governance and some aspects of sort of the community. It seems like the community is a huge deal. Like the fact that it exists and how large it is for Kubernetes. Can you talk a little bit about it? Is it still growing? Like what's happening with the community right now?
The community is the single most important facet of the Kubernetes project. It is the reason that Kubernetes is as successful as it has been. The community it's enormous. It's overwhelming, honestly. The last time I looked, we had over 2,500 contributors across all of our different repos, coming from literally hundreds of companies. We're pulling in somewhere between 40 and 50 commits a day to the code base. We're pushing our 50,000 commit number soon. It's incredible that we have this many people working on this little idea that we had, and the community has just been such an integral part of the process. It has simultaneously forced us to be more open with how we do things, which has been really good for the project, but it's also forced us to let go of parts that we wanted to work on or that historically we've sort of owned, and we've let community own things, and it's been, say, overall wildly successful. And incredibly difficult.
So I'm wondering, we mentioned community. How big is the community? Like, how many contributors could you tell a little bit how many people are actually working on Kubernetes? Not like let alone using it, but actually actively developing it.
Sure. The number of total unique contributors is over 2,500. That doesn't mean that 2,500 people are contributing on a regular basis, right? A lot of those are one-time contributions or people who contributed and then went away, to do something else. I don't have the number off the top of my head, but I'd say it's probably on the order of several hundred 30-day unique contributors, from dozens and dozens of companies. Obviously we have big contributing companies like Red Hat, and we have many, many smaller contributing companies, and we have a lot of people who are just starting to contribute. Our Slack is filled with thousands of people asking and answering questions from each other all day long. Our mailing list is incredibly useful, and people are there answering questions for each other. We have thousands of GitHub forks. We have hundreds of meetups around the world. By most metrics, we're the busiest project on GitHub. So, those are some basic numbers for you.
Nice. I like to think myself as one of the contributors because I fixed one typo in the documentation once.
There you go. You are one of those 2,500.
Yep.
I better do something. I better get stuck in there.
Yep. I got a cool T-shirt that said contributor with a K.
Nice.
So there you go. So let's get started a little bit with more technical stuff. Kubernetes 1.7 has a lot of new things. Yeah. I was looking at the release notes, and it's kind of amazing and almost like scary how many new things are coming. But why don't you tell us a little bit about what are the main topics and your favorite features, maybe?
Sure. The release notes are overwhelming, right? It's like 30 pages of release notes. You have to remember, Kubernetes is an enormous surface area, right? Everything from network infrastructure to the API to the machinery that drives the APIs to all the workloads. All of these things are being driven by different teams, right? We have over 100 people at Google working on it, and those people are doing full-time work. So the rate of change is just huge. It's not really that surprising when you look at the surface area of it, right? It's when you sit down to try to read the release notes and ingest the whole thing at once that it becomes scary. Yeah. What are my favorite parts? Obviously I'm a little biased towards the parts that I'm closest to, and I'm close to them because I'm interested in them. But some of the things that I thought were really cool in the 1.7 release are things like network policy, which went GA. We have, which lets you sort of describe micro segmentation on your network. We have this ability to preserve client IPs across load balancers now, which is something that people asked for a long time. We have this new aggregated API system, which I think is just phenomenally cool. We've been talking about it for literally 2 years and working out how to get it done. And now that it works, it's actually pretty awesome. We have lots of new sort of small features that make the overall distributedness of the system better. Things like initializers, which let you do out-of-process asynchronous initialization of objects. We have audit logging, finally, and it's just a super cool feature for you to be able to see, who changed what and when about my cluster. We have the beginnings of a much more secure system. We have encryption at rest. we're working on moving all the cloud providers out of our tree. I like to say I'm kicking Google out of Kubernetes. And it's a really big deal because it's going to help the code base scale, and it's going to allow us to expand more broadly. We've got a new metrics API, which means we can finally start to do things like auto-scaling based on custom metrics. The internal runtime interface, the CRI, we removed all of the legacy Docker code. It's now only CRI Docker, which is a phenomenal internal cleanup. We have local storage that's been introduced, which is something that people have been asking for a long time. I mean, I could go on, but these are some of the things that sort of jump out to me about this release.
Yeah, so there's really nothing going on at all. Like, it's just pretty quiet.
Yeah, Kubernetes is really not, I don't know, 200 engineers, they're not doing much.
Yeah, I don't know.
Now, so instead of trying to list all of them, because as you mentioned, there's so many of them, I think that we have a list of like the ones that we consider to be the coolest. So why don't you go first with some of your favorites, and we ask Tim to explain a little bit why it's important.
Yeah, so Tim actually brought up one of my favorites. So it feels like Kubernetes in the beginning was kind of like, we think we're going to solve sort of the 80% rule. Like, this is what we think 80% of the people need. And then sort of as we've headed down the roadmap, things have got more. We still do that, but we're now going to allow you to have hooks and things you can do to really customize Kubernetes to be exactly what you need for exactly what your workload is. So that brings me to things like the API aggregation type stuff that you alluded to earlier. Can you sort of explain what that is and how that works? I think this is a really, really cool thing.
Sure. So one of the things I think that makes Kubernetes really powerful is the consistent API. We have one API server that has a set of semantics for how you interact with it, and all of our APIs conform to that same API server. And they're all discoverable in the same way, and they're all sort of interoperable in the same way. And what that means is you can have one set of tooling and one sort of client concept that works across all of those different APIs. And like you said, it's sort of the 80% rule, although I don't think we're quite at 80% yet. But the things that we know how to handle sort of natively built into Kubernetes. And then there's this wide landscape of ideas that people have of things either that they want to add to Kubernetes, but they need to prove themselves first, or things that they don't want to add to Kubernetes, but they want to use with Kubernetes in the same way as Kubernetes, but probably will never be part of the core system. And we've heard the people who want to do this, and what we've given them is this aggregated API. And so what it means is you can essentially run your own program in your cluster or out of your cluster. It doesn't really matter. The program will register with the API server as a specific sub API, and then you can use all the existing tooling that you've got, kube control and all of the other pieces, and they just work with the new API as if that type that you just registered was part of the built-in API. When you post an HTTP request to our API server, it gets passed through onto your own API server where you have a chance to validate it, do admission control, do sanity checking of the input, reject the request if you need to, and if you accept it, then it becomes a stored object in the same way that anything else in the Kubernetes system works. And it's essentially transparent to the client. And because something like kubectl does automatic probing of the API server, you can, in fact, just start using it without any changes needed in your client.
So is this got a relationship to custom resource definitions? Is that right?
Yeah. So we started talking about this aggregated API idea a couple years ago. And when we scoped it out, it was sort of big and hairy and complicated. And so the predecessor to custom resource definitions, which was third-party resources, was sort of the poor man's version of aggregated API. It was a simple way to do essentially the CRUD operations, create, read, update, and destroy, but it didn't have the opportunity for you to hook in and do synchronous validation, right? You could never do a sort of schematic check on it to make sure that, say you have an integer field and it has to be greater than 10, there was no way for us to validate that, right? You had to do that sort of after the fact. And that was great, and it lets people do a lot of really neat prototyping stuff really, really cheaply. But I think the aggregated API gives you a much more robust way to take those ideas into production.
So would you say that custom resource definitions is kind of like good way to start if you want to enhance the API, but if you want to get more serious, you should go with API aggregation, or should you just use API aggregation rather than custom resource definitions?
I think you said it right. I think custom resource definition is the way you start. It's the lowest barrier to entry to making extensions to the Kubernetes API. In fact, we request anybody who's trying to propose a new Kubernetes API that you start with something like a CRD, and you demonstrate the value of what you're working on. You work out the API and you implement your backends against it, and you sort of get everything sorted out. And then when that looks pretty good, then we can talk about inclusion as a built-in API, or we can talk about moving it to something like aggregated API, or you can leave it as a CRD if that's sufficient for you and it satisfies what you need to do. CRD is the lowest barrier to entry. Aggregated API is a significantly higher barrier to entry, but not nearly as high as adding something built in.
Cool. Let's move to the next topic. I'm curious about this thing because I've always heard about it as being something that people consider an anti-pattern, which is pet sets or stateful sets. You're adding more things to stateful sets on this release. Could you tell us a little bit about what is first stateful sets and then when to use them?
Sure. Now, pet set is sort of a dirty word. So,
yeah, I know.
So the idea stems from this pets cattle analogy that has sort of made its way around the space. And Kubernetes really embraces the idea of cattle and scale out and replicas. And that's really good for a large class of work where you can just add more copies of your thing and it will scale. It doesn't really satisfy the case of, I have a database, right? I have something that's really important and I have to protect that state. And this pattern sort of is at the bottom of every major application, right? It's the database, it's your Mongo, it's your MySQL. So once we sort of decided we were successful enough at stateless applications, these scale out web serving sort of applications, people wanted to run stateful applications. They said, well, how does Google do it? And we said, well, the Google model within Borg is a little different than the Kubernetes model. And we took a hard look at what people were trying to do, and we came up with this idea of sort of a different primitive that has some of the same properties as deployments or replica sets, but is different in really fundamental ways. And that was what became what was then called pet set, which evolved into stateful set. And some of the differences are things like you're not going to scale it out in general, and if you do, it's not a cavalier operation, right? You can't just throw another replica at it. It's typically something where maybe you have a quorum, and so you have to have an odd number of replicas. Or you need to do sort of an introduction step where you introduce a new replica and it meets all of the other replicas, and then you can add a second one. So you can't add 5 at a time, for example.
Yeah.
And the identity of these replicas sort of matters, right? Whether you're shard 1 or shard 2 actually is significant. And maybe you have state that you're storing that is related to your particular index in this array. And so these are the sort of primitives that are added, right? Within a replica set or a deployment, replicas are all assumed fungible. You don't have an index. You don't have an ordinal number. Nobody is the 0th entry. And within a pet set or a stateful set, you absolutely do, right? You know exactly how many replicas you have, and you know which one you are. And it is tied to volumes, so you can have a volume that goes with each copy of your stateful set application. And there's rules about how upgrades are done across stateful set replicas. And we've taken the assumption that there must be state here, so be super, super careful. And we've traded, instead of being really fast at doing rolling updates, it's much more careful and much more safe, which means things are going to be necessarily slower and more complicated. So now that said, what's changed in 1.7 is we've extended it to support things like rolling updates. Right. So previously, stateful set didn't even support rolling update. If you wanted to update your application, you had to manually go through and remove each replica and let each replica get replaced. And so now we actually have a rolling update ability where you can kick it and it will do that automatically for you.
Awesome. So Francesc and I have listed both two of our favorite sort of things in this list. Tim, do you have a particular favorite one you want to go deeper onto?
I love network policy. I think it's a really cool API. It's been beta for a while, but it's finally GA. Network policy lets you sort of abstractly describe the graph of your application, like which things are allowed to talk to which other things. And then you can enforce at the network level, anything that's not described by this graph is disallowed. And so I can say, like, my front ends can talk to my middle tier, and my middle tier can talk to my database. My front ends can never talk to my database. And my front ends can never talk to each other, because that would be weird. And once I've drawn that graph, then if I have the right sort of network installation, now it's an abstract API, right? So if you have the right network config, then you turn it on and the network config will start enforcing it. And suddenly those packets between the front end and the database just get dropped. They go away into the ether, and there's nothing that, if your front end got compromised somehow, it cannot attack the database.
That's super cool. I didn't know that. So as an interesting aside then, Is that somehow related to what's going on in, say, the Istio project? Or is this outside of your purview?
No, so network policy is at the layer 3. Layer 4, IP plus port. Istio is at layer 7, right? It's really aware of identity and it's using that as its rules. They are very similar and I think they're complementary. The network policy can act as a really nice backstop behind Istio policies or layer 7 policies. Istio is just a specific implementation of that. So I think they work well together. I think that space is very new and we're still trying to figure out exactly what is going to happen there.
Cool. So we already have been talking for over 20 minutes. So we're almost running out of time. But before we do that, I actually would like to talk about a little bit about the future. So is there anything on the roadmap 1.8 or later that you'd like to mention that you're excited about?
I don't want to pick on any one thing from like the 1.8 roadmap. There's a bunch of features. You can go look at the features repo and see what people are working on for 1.8. I like to think a little bit further out and see what the major trends within the system are. I think extensions and modularity is a major trend. You've seen a lot of work happening here with CRDs, with aggregated APIs, with plugin systems, with things like Ingress, which are sort of abstract APIs, with cloud providers, with now kube control plugins. You can actually do client-side plugins. I think that the directions with Istio are really interesting. I think we don't really know what we're doing there yet, but I think that Istio has demonstrated that this is a really cool space. I think things like Service Broker are really exciting, and I think that is going to be a big part of how people consume services and Kubernetes in the future. I'm looking forward to better cloud support as more clouds support Kubernetes more natively. We're getting better primitives out of these clouds. I know the team here at Google Cloud is obviously working very hard to make Google Cloud support containers more directly. I think we're going to see really cool things with easier and richer installation and configuration of clusters, more consistent hybrid stories, so you can run clusters in multiple locations and sort of use the same tools. Right now, it's open source, so it's sort of the Wild West, and everybody's doing their own thing. And I think we're coming to a place where we can start to get some convergence. I think the local storage idea is just scratching the surface. I think we're going to see a lot better system debuggability, introspection, a lot less reasons to SSH into your machines, and a lot better sort of automatic tooling. These are the big trends that I'm paying attention to. Security, obviously, we're getting better at, with the encryption at rest, we'll have more secrets and sort of auth plugins and secret plugins and encryption providers and automatic identity providers and those sorts of things.
Nice. Well, I have to ask a question.
Yeah.
kubectl, kube control, or kube cuddle?
In my real life, I say kube cuddle. When I'm talking, when I'm talking publicly, I sometimes say kube control because apparently that's what most people expect it to be. But I still think they're wrong, and it's kube cuddle.
Nice. I was curious because you actually used both during the podcast.
So yes, I caught myself. I try to say kube control when I'm presenting something, and I caught myself say kube cuddle once.
I think kube cuddle is the way to go anyway. So yeah,
I have a twitch in my eye. It's probably going to go away any minute now, I'm sure.
Well, I mean, the alternative that I proposed on Twitter, which didn't get a whole lot of likes, was kubectl, which is obviously in alignment, with ioctl, right?
Yeah, true. Yeah.
Kubectl.
Oh, wow.
You know what? I could get behind that. I could totally get behind that.
We need to make t-shirts.
That's fantastic. Cool. All right. Well, we could talk to you for ages and ages and ages. But before we wrap up, is there anything at all that you want to mention or plug, or is there a feature that you just think is amazing and we haven't managed to cover it that you want to talk about before we wrap up things here?
I mean, I think I've talked about all my favorite pet features. The thing I want to plug most is the community. I want people who are listening who maybe are using Kubernetes but aren't really participating to come and participate. The water's warm. Come and file bugs, right? Try things out, and every time something doesn't work the way you think it should, every time you have a little bit of friction, like file a bug. This is how I became the top bug filer, is by trying the system out and trying to push the boundaries of what the API can do and finding weird places where things didn't work the way I expected them. And, surprise is never a good thing. So I want everybody who's using the system to file a bug every time you get surprised and come in. And if you've got, some pet thing that you want to see changed, like the code is daunting because of the size of it, but we'll help you find the places where you need to tie in and scratch your own itches. This is open source. It's been a wildly successful open source project. I think it's demonstrated the real power of open source. I just want more people to participate and engage. We need help on things like contributor experience. We need help on things like tooling. You don't have to be, a PhD systems engineer to participate in this community. You can come in and help us with our build systems, with our shell scripts, with our tools and test infrastructure, and with our GitHub bots. All of these things I think are relatively low barrier to entry. Even docs, just contributing to the docs is massively important. The number one complaint that we hear about Kubernetes over and over again is that the docs could be better. And they're getting better. We need help. Many hands make light work.
That reminds me, I have a patch that I've had as a to-do that I've been wanting to put in for like
you
4
should
weeks
do
now
it.
that I should do.
This time next year, I'd like the contributors number to be 5,000 instead of 2,500.
Nice.
That's challenging, but okay.
So
we'll
hold
see.
on. We're recording on the 28th of July. If we come back in a year's time, we'll have Tim on. We'll see if you're right.
Deal.
Awesome. Well, Tim, thank you so much for spending time with us. We really appreciate it. This has been a great conversation around Kubernetes, and thank you so much for helping start the project. I mean, I love Kubernetes. It's one of my favorite things.
Yeah. Thank you so much.
So
thank you so much for joining us.
Thank you guys for having me.
Thanks again to Tim for joining us for today's interview. As we've said a couple of times, definitely wanted to have Tim on the podcast for a really, really, really long time. So glad we could manage to find a great time for us to sit down and have a chat. Learned a whole bunch of stuff about Kubernetes 1.7. I'm super excited about this release.
Yeah, this was one of those interviews that I really didn't want to finish.
Yeah.
So many questions, and he's such a cool guy. I wanted to keep talking to him. But anyway, I guess it's time to go with our question of the week, which fortunately is about the same topic.
Yeah, so it seems like a fairly common question in a lot of ways, and I've definitely come across this before, where it's like, okay, I have pods, I have containers. How much stuff do I put inside my containers? How much stuff do I put inside my pods? Is there this magical silver bullet for a rule that I can just apply for just giving me the best way to do this? Francesc, tell me more.
The answer is no. There's no silver bullet, because that's the whole point about silver bullets. They do not. Maybe they exist. I don't know.
They exist for werewolves.
Yeah, whatever. Sure. Okay. Anyway, not really, but there's some good practices or a good way of understanding what pods versus containers are that might help you guiding the decision between putting everything in a pod or everything in a container or whatever you want to do. And there's actually really good talk by a very good friend, Tim Hockin.
Strangely that.
Strangely. We'll have a link in the show notes, and it's called Kubernetes Understanding Pods versus Containers. And he uses a very cool metaphor, which is, imagine that you're thirsty, right? And if you're thirsty, I could give you just a bunch of particles, like electrons and neutrons and protons, and then it's then you do it, right? And it's sure, but no, right?
Yep.
That's not very helpful. That could be well, you have all of these different libraries and tools and things, and it just gives them to you.
Yep.
You want them to be organized in some way in order to be useful. So yeah, you cannot drink fundamental particles. That's not a good idea. The second part is well, I'm just going to give you hydrogen and oxygen and just you figure out, right? And that might be containers, right? You have a container which is hydrogen, which hydrogen, by the way, is one proton, one neutron, one electron. Oxygen is one proton, one neutron, one electron. So you have that, and just okay, still not good enough, right? So sometimes what a container is not enough. You want a higher level of organization. And that's exactly when you put them together and you're oh, what if I put together the hydrogen and the oxygen, and I put two hydrogens and one oxygen. And now all of a sudden, there's two containers of hydrogen, one container of oxygen, and you have water, which is a pod.
Cool.
So that's the whole idea, right? Hydrogen is a useful thing by itself, but it is when you put it together with another hydrogen and oxygen that you get this other useful thing, which is water. Imagine that you want a sweet water. Sweet water, is it called?
Sweet water, yeah.
Yeah, whatever.
Water with sugar in it.
Sugary water.
Yeah.
You could put it together the same in a single pot. You could put the sugar and the water. But then the problem is that the sweetness of the end product is fixed, right?
Yep.
You cannot augment the amount of water or sugar without augmenting the
And
other
maybe
one.
I find it too sweet.
Yeah, so The whole idea is that, well, if you have it in different pods, all of a sudden your cluster can scale up the amount of water or scale down the amount of sugar independently from each other. And that's the whole idea. So you have containers, which are like basic useful things, hydrogen, oxygen. Then you have pods, which are useful things, which are like water and sugar. And since they're separated, you can actually scale them differently. And I think that's a beautiful metaphor.
I think that works really well. So basically, I want to think about what are the things that need to be held together, but what are the things that I want to keep separate? Yeah. And making sure those two rules don't necessarily overlap in ways that I don't mean them to.
If we go to an example like with a 3-layered tier, whatever.
So I might have like my database. I don't want that to scale up and down. I want that to stay relatively static.
Yeah.
So that's one. That might be a database process that runs inside a container, probably inside something like a stateful set. And I might run just one of them.
Or you may have like a distributed one, which you have like a cluster, and you have like 3 of them, but they're like 3 and they're pretty stable. They don't move around.
Yep.
Yeah. And then you have the web servers, and the web servers, maybe you have more of those. And maybe inside of every single web server, there's a pod, and you have like one thing, which is a microservice to do something, and then the other one, which is log. Logging without the microservice doesn't make any sense, right? So you put them together inside of a pod. But if you have like customer microservice and like content microservice, they might be different because maybe you need more traffic into customers than the other one that is like content.
Yep.
So that's a whole metaphor.
Yeah.
Water, sure.
And by the same token, you wouldn't want to mix your web stuff with your database.
Yeah.
Because that would we don't want to scale up the database at the same time as we scale up our web stuff and keep that all separate. I like that. That's a cool metaphor. I like it.
It's a very, very good metaphor. So I thought it was a really good way of explaining it. I do not think there's a recording for this talk. But the slides are there, so we'll have a link in the show notes so you can check them out.
Wonderful. All right, Francesc, before we wrap up today, what are you up to? Where are you going? Is there a Just for Funk? I'm sure there's a Just for Funk.
So there was a Just for Funk that I published last week, and it's doing really well. I think it almost like 4,000 views. It's about testing web servers and stuff like that, which apparently people like.
Nice.
After that, I will be releasing one next week, which might include some guest stars, such as this guy called Mark Mandel. If he ever records with me, who knows?
Who
knows? But other than that, I'm going to be going to Spain to enjoy some holidays, and then I'll be back in September. I'm not sure when I'm going to be in September. I might go to Australia.
Nice.
Yeah.
That'd be good.
It's Sydney.
The irony is impressive, but it's good.
What about you?
What am I up to? So I'm going anywhere until the end of August, where I will be speaking at PAX Dev and then attending PAX itself. After that, September's crazy. I'll be at GamerCon Las Vegas. I'll be at Austin Game Conference, and I'll be attending Strange Loop as well, one of my favorite conferences.
Strange Loop. Yeah, that's going to be fun.
Yep, super, super excited about all of that stuff.
Very cool.
Awesome.
Well, it's almost time to finish, but before we finish, there is something that we have not done in a very long time.
Let's do it.
Yeah, which is, so we love talking to you, people. Send us your questions of the week, send us your cool things, send us everything. Send us even jokes. We love jokes. Or pictures of puppies.
Yep.
In order to do so, you have a bunch of different ways of doing it. One of them is Twitter.
At GCP Podcast.
We're also on Google+.
Plus GCP Podcast.
We also have a subreddit.
/r/GCP Podcast.
We have a webpage.
GCPpodcast.com.
With emails.
At hello@GCPPodcast.
Too many ads there, but whatever. And finally, we are also on Slack.
At the #podcast channel on the GCP community Slack. You can find it bit.ly/GCP-Slack.
That is amazing that you remember that. So anyway, thanks, Mark, so much for taking the time today to talk about Kubernetes with Tim Hockin. Thanks again to Tim Hockin for letting us interview him.
Yeah, and thank you everyone for listening, and we'll see you all next week.
See you all next week.